Boom, real voice jump scare. My text-to-speech doesn't work anymore and I don't want to deal with it. Hello guys, gals and NBs, let's have some fun. Let's make something that looks a little bit like this. And this is just sort of to start playing around with pops, doing stuff that maybe we already know how to do or know how to do in tops, and sort of just seeing what pops has to offer in that space. Yeah, we'll be looking a little bit at groups, a little bit at trail, trying to work with the attribute system, and hopefully we won't crash our computer too many times in the process. So make sure you save. Yeah, let's get started. Okay, so here we are in the experimental version of Touchdesigner. So let's get a 3D model in. Here I've downloaded this, and you can make your own or whatever, and I'm loading it in as an OBJ, and it's already in a pops format. So let's make sure to just, so that we're all doing the same thing here, we can rotate this so that up is in the y-axis and left to right is in the x-axis and depth is in the z-axis. So it goes green. Now let's also bring this into a normalized range, 0 to 1. And we can do that with a normalized pop. And then we have a squishy boy. We don't want that, so let's aspect correct him. And let's also, one more time, do a transform and just transform this guy so he's standing. And I'm just eyeballing it until he's somewhat in the center. So he's standing directly on the XZ plane and stretching up until exactly 1. So that's nice. Let's turn these viewers off and let's sprinkle some points. And we can do that with a sprinkle pop, and we want quite a lot of points here, so maybe even like 512 to the power of 2 might be a good amount. And in this way, we basically just have a point cloud. And you don't need to create point primitives, so we are just sort of like this. So that's nice. And let's connect this to a null that we call init. Let's call it init null. And before our initializer here, let's also create some attributes. So there's 2 attributes that I know that we're going to want to have here. And that's one attribute called life and another attribute called velocity, VEL. And I'm setting that as a size 3 vector, so it's a float 3. And both of these are initialized to 0. Nice. Let's connect this to a null, and we name that feedback end null. And let's start by instancing this right now, and let's instance some boxes. So let's have a box here, and let's set it to like a really tiny size, like 0.1, maybe 0.1. And let's just use the copy pop here to instance this. And now we have a bunch of points, and they're a touch too big. Maybe here, 0.04. that might be a good start, and then we'll take a look at more of that later. And let's chuck that into a geometry, and let's create our little render network here. So we're gonna need a camera. The camera is gonna want to have a null that we can look at. So we grab that to the camera, assign that as a look at, and let's put that right here. We're gonna need a material. Let's use a PBR, physically based rendering, and we're gonna want to have a render. Apart from that, we're also gonna want to have a light. So something that tells us where the light is coming from. And let's grab this to a reorder, and let's just set the alpha to 1. And then we can keep this in the background here. It's very dark now. So 2 reasons around that. First of all, let's just for now grab an environment light. And in that environment light, we can connect a constant to that and a null. And later we can use a proper environment HDRI here, but for now we'll just do it like this so that we can see what we're doing. Okay, let's move the camera in a bit. Let's move the null look up a bit. Let's also move the camera up a touch so we're not exactly on ground level. Maybe there. We still want to look up towards our character, I think. That's how David was meant to be seen. That's actually true. Let's turn on some soft shadows, and let's turn this into a cone light, and let's just move this light to somewhere like this. Okay, that's nice. So let's create our little feedback system here. First, let's use a feedback pop, and let's create a keyboard in here just so that we can reset it. Nice. Let's grab the feedback end null and assign that. And let's add a noise in here and see what happens. Yes, we have an exploding guy. So that's fun. Let's reset that with the keyboard in, and if we turn the amplitude down a little bit, he's going to be exploding a little bit slower. So this is fun, but maybe we want something a little bit more interesting here. For example, one thing we want is for the particles' forces to sort of remember a little bit their force and have a little bit more momentum. So we can do that by using our velocity attribute and keep updating that every frame. So first of all, let's make sure this one outputs only the noise. And let's set it to a vector, so it actually outputs a vec3 and not a float value. Like you can think of vec3 as RGB if you're new to, if you're used to pops, or if you're used to tops but are new to pops. Let's use a math mix here. Math mix allows us to we're going to use so many math mixes. So we can call this one update velocity, and we can say we're gonna need a uniform here, and we can call this one vel decay, and I just put a U in front of my uniforms because so, and then we can say the velocity gets multiplied by the vel decay. So it falls off a little bit every frame. It falls off quite a bit every frame. And then we can say let's actually create another uniform here and call it noise amp, and we can set that one to something like 0.001, and then we can say A times B, so noise times U noise amp, and then we can say A plus B, so we take the velocity and we add some noise to it. And then we can also update our positions here. So we can say position plus velocity. And we're probably going to want to turn this one up a bit then. Yeah, so our noise has an amplitude of 1 here. This is how that math mix looks. And we should probably call it update velocity and position, just for clarity. So that's nice right now. Something not super interesting, but a little bit interesting. But we also have the issue that we're sort of not returning home right now. So we want to create a little system that can return stuff back home, a little life management. And that is actually really easy to do now in Pops. So we can use the math mix here and we can name that life management. And this one is going to need a uniform, and we can call that uLifeAdd. And let's just set that to 0.01 for now. We'll set that up smartly a little bit later. And let's say A plus B, life plus uLifeAdd. And I'm gonna grab a pop to top here, just so we can see what's going on. And let's look at the life. So here we have our life attribute, which just keeps increasing every frame, which is what we're doing here. We're adding that uLifeAdd to it. So we can check it though. So let's see if life is greater than 1.0, let's create the new attribute here and let's call it dead. So if life is greater than 1, we have an attribute called dead. And let's look at dead in the green channel here. So no green, book. Duk. There. So we can see it's sort of ticking. And in that case, we can also say, we can create a little ternary statement here. So A if C, else B. That one is easiest to think about from back to front. So if dead, A is 0, else life. And we are putting this in the life. So it's the life, if dead is true, which it is when life is greater than 1, then we go back to 0. Else, just keep being life, and we'll put that in the life channel. And now we have a little thing that just keeps ticking and ticking forever and ever. So that's nice. No need for anything complicated there. We can create another little ternary statement here, and we can say something like we want to do the same thing but for the positions. So we can grab the initial positions here from the init null. Right. And then we can say if dead, go to your initial positions, which is this one in 1p. Otherwise, just be positions and put that into the p positions result scope. And now we have a constantly resetting feedback loop. So that's kind of neat, right? We can also create another one and do the same thing. Let's say if you are dead, go to the initial velocity, otherwise just keep being your regular velocity, and that's velocity for you. So now we do the same thing for the velocity also. We are resetting that to its original positions. And now if we were to just sort of stagger the starting positions here, sort of with a random, and let's just set that, and let's output that into life. So we'll have a offset starting positions. We're gonna have a very nice sort of rudimentary life component. We can also, after this init here, we can create a random and set that to an attribute called random. And then in here, we can move this up, move block, and we can say A times B. So we take the random in from the second input, and we multiply that by uLifeAdd, and we can create an attribute called lifeAdd. And we can set that, use that here instead. And now they're gonna have random life variants also. Some of them are gonna have an infinite life, so maybe that's not something we want, so we can turn this one up a little bit. In the output, I'm also just gonna delete the life add because we're never gonna use that. Nice. Let's take these three, the random, life management, and let's just collapse selected. And you can jump forward in the tutorial if you don't want to turn this into a little component. So let's make sure this one is number 1. Let's name this one to feedback input, and let's name this one to init p input, init p, and val input. Nice. And let's customize this component, the parent component. So I right clicked and I pressed custom parent component, and we're gonna want lifetime in seconds as a float. We're gonna want to have life variance as a float, and the life variance I'm actually gonna clamp between 0 and 1, so we don't go into any negative shenanigans which will mess this up. And then I'm gonna add a third one called delta time, and this is just sort of the time in seconds between each frame, so which is 1 divided by me dot time dot rate. You can also use step seconds there, but that can be tricky in certain aspects, so I prefer to use 1 divided by me.time.rate for these sort of reasons. Let's put it to 5 seconds. So how much do we need to add for it to add up to, so we wanted to go from 0 to 1 in the span of 5 seconds. So we know that if we put this one in, it's going to go, because this is 1 divided by 60, and we're running this at 60, so we know that this is going to be equal to 1. So then we just want to divide that by how many seconds we have, right? So because this is in 1 second, if we divide that by 5, then that's 5 seconds. So I'm turning this into a float too right now, just for a second, just so I can grab this one, so I don't have to type it out. And I control exit, and I divide it by that value, and then I turn this back into a float. So yeah, now we have a little life component here that we can use to sort of set the time. Oops, I forgot to open parent parameters, and let's drop this one into value A here, and let's just say 1 minus. So this one creates a bigger range, and this becomes a yeah, you get it. So the range only becomes bigger. The lifetime seconds is essentially your minimum lifetime, and then this becomes your sort of the variance above that. You can set this up differently, so this is instead your maximum lifetime, but I leave that as an exercise to the reader. Okay, let's think about something fun we can do here. Let's create a little field that affects our noise. So, and I want to define that field by our starting positions here. So let's create a field, and let's set that to the Y plane. Right, and let's drop in a math mix here, and let's call it field noise stuff, whatever. It's a sketch. And let's plug this one into here. So we have an input there, and let's combine these. So let's multiply the noise by the weight, which is the attribute that this one is creating. And it's a Y plane, and if we move that Y plane up a little bit, we're going to see how it starts affecting our character. I want to move in the opposite direction, so then we can just invert it, right? And let's create a little bit of a transition range here, maybe 0.25. And let's also create a constant here, just so we can use that as a slider. Connect that to a null and hook that up to this transform. And I think I want to actually multiply, let's set the range to maybe 1.3. So when we're all the way up, it affects nothing. And then we can sort of travel down this character to start the process. Nice. Okay. There's actually might want to just change the seed up a little bit. Okay, another thing I want to do is I want to just like randomly rotate these boxes a bit. So after the feedback end here, I'm going to create an attribute. I'm going to create a few attributes here. So one of them is rot, which is of size 3. Another one is color, because we're gonna, I'm gonna use the built-in drop-down here for color, because we know that we're gonna be using the some stuff for color. Let's also initialize one called point scale, which is of size 1. This just sort of initializes these attributes for us. Anyways, let's create a random here. And let's set that to the rotation. And I want that to go from negative 180 to positive 180. And I'm going to use that to rotate our boxes a little bit, just so they have a little bit more offset, creates a little bit more visual interest. Let's turn the roughness down. Let's turn the dimmer down. Nice. And maybe here in this attribute, if we do this, so let's also copy, use some template attributes and use the color, and then it goes dark because he disappears. So let's actually turn this up a little bit, like to 0.5 maybe. So yeah, now we have a dude that we can sort of scroll through, down and up and down and so on. And in update velocity, we can sort of set a larger noise scale if we want to. We can also do that in the noise, because it gives us a little bit more sort of granular control. Let's actually abs time dot seconds times 0.05 this, just so we get a little bit of movement in to animate this noise. Let's move it up a little bit. So yeah, that's already kind of a fun idea that you can use, but this could be done easily. Well, not this easily, but it could be done in tops too. So let's actually start doing some slightly fun pop stuff here. So one thing we can do here, let's go after the attribute here. Actually after the random, let's say, before the copy. Let's create a group. And I'm gonna name this the trail group. And let's thin it out quite significantly, so it's like 0.9. And in order to check this, let's do a thing for color here. So let's do a math, and let's set p dot 2 and 3. So the color 1, and 2. In the trail group, let's multiply that by 0. And let's turn this color up a bit. And let's check out this group. So yeah, here we can see if we thin this out a little bit less, so we can see how many of the participants belong to that group. So if we set it to something like here, it's just a few of them, but I want it to be quite few, so maybe 0.8 of them. And then let's set the point scale. And for that, we can use this math that we already have. And we can set point scale to, and in this group point scale, let's multiply it by, like, I don't know, 5. Maybe even 8. And in this copy, in the template, let's use the point scale here. And we also need to initialize our point scale to 1. So yeah, now we have a few of these points which are a lot larger, which looks kind of ugly right now. Don't worry about it, as usual. What do we want to do here? First of all, I only want them to grow larger when we are being affected here. So I'm actually gonna just combine this attribute somewhere, so of the weight here. So let's create an attribute combine, and I'm doing this after the feedback loop. So and I'm just adding a pop here just for a little bit of cleanliness, and let's just bring in the weight from there. And then in this, let's create a math mix, and let's name this one trail group scale. Let's say that the A times B, so we take the point scale and multiply that by our weight. And now everything disappeared. That was because I didn't select just my trail group. So yeah, now that only is affected by everything within this weight. I'm gonna delete this math, and I am going to also say create a uniform here called scale mult. I'm just using this in one place, so naming isn't that important. Let's set it to 8. And let's combine these. Let's say A times B. Let's take the point scale times U scale mult. Now we have this sort of behavior. Now there's another thing I want to do to the point scale here, which goes for all of these boxes, both big and small, and that's to make them fade in and out. And I want to do that according to the lifetime. So when they start their lifetime, they're very small, then they grow large, and then they shrink back to small again. And let me just show you how I'm thinking to do this. So we have the lifetime, which is a value between 0 and 1. So something like this, right? So let's take an expression here and look at this little expression. Let's take the sine of that. So math.sine. So we're taking like the upper half of a sine wave here. And we multiply that by math.pi. not pooey, pi. And then we get this sort of shape, and that's a nice shape, I think. And of course you can like shape this in other interesting ways that you might be into, but I'm gonna opt for that way. So after the attribute where we've set our point scale, let's create a math mix, and in that we're gonna need a uniform that we call pi, and let's just set that to math.pi. Wish there was a way to create constants. Anyway, there probably is, and I'm just missing it. So we can take the point scale, multiply that by pi, and now they're just 3 times larger. And then we take the sine of the point scale, and now they are tiny, and that's because we're in degrees and we want to be in radians. And what's going on? Yes, I know what's up. Let's just create this one called pi so it looks the same as yours. That's because I haven't designed this to the lifetime. So obviously at the very top here, move block, and let's just say A. So our lifetime is equal to point scale. And now we have these little boxes which sort of is equal to math.pi. And now we have boxes that are increasing in size and decreasing in size here. So that's neat. That's nice. If that's what you're into. Let's also create another, after this group, let's make the big boxes shine a little bit more red. So let's not scale them quite that much. And so we can use a texture lookup, and we can actually use the like something between 0 and 1, and in that case we have like the life here, and we can use a texture like a ramp and use that here and output that into color. And if we make it red, it's like this, and if we make the beginning white, and then during their lifetime they go between sort of red and white here, which is nice. It's actually quite nice. I like that a little bit more than I wanted to. So yeah, let's do that. And then let's create another one that does the exact same thing. So let's just copy and paste it, and let's create another ramp. Maybe has a deeper red to it. Maybe it goes from something a little bit bluish also. Let's use that as our lookup here. But for this one, we will only assign this to the trail group. So maybe that one goes the opposite way. I don't know, I'm kind of freestyling now. Maybe it'll be blue. It's a little bit too much party. let's see. Let's actually turn this red down a little bit. Let's make these ones a little bit bluish. Yeah, there we go. And then our main group here is has this sort of white to red fade. So yeah, that's something that would have been not impossible in Pops, but definitely not as quick. So we can move through our character here and dissolve him and rebuild him. Let's turn the metallic down and the roughness a little bit up. Okay, let's create some funky little trails for this guy also. Oh, and when working in Pops, good to just turn off the viewers, because it can get a little bit expensive. Okay, let's create some nice little trails here also, just for fun. So let's select this. Let's grab it from here. Let's do the Touchdesigner way and create a null from here, and let's select that null. And one thing we're gonna want to do here is we're gonna want to delete a bunch of these points. Which ones are we deleting? Well, we're deleting based on a group, right? So let's delete based on the trail group and let's invert that. So this way we're only keeping the ones that we have in the trail group, the ones that are having like a little bit more of a, yeah, the red ones, the ones we've been working on. You know what I'm talking about. And especially when working on Mac, it might be important to copy this back to the CPU. I'm not sure this is as important on PC, and I'm also not sure it's as fast on PC, but I haven't tried it. Okay, and then we can connect a trail here. And yeah, we have a nice trail, but I see it too, don't worry about it. Right. Now there's one thing that I don't think any one of us are happy with, and that's when the particles dies, it sort of disappears. So let's actually delete those points. So we can split the line strip on the attribute called dead, and the other way around here. So whenever we get the dead attribute, we just sort of delete those points and forget that they happened. Right, so this is nice. It's also like a little bit stiff, these trails, in my opinion. So let's add some noise to them. And we can do that with the attribute called age here. And let's grab the age in seconds. And then we can sort of just add some noise. Hold on. Right, so if we add noise to our trails here, it looks like this, but then this just looks like it doesn't belong anymore. So let's, under output, let's just go to none, and let's make sure it's actually a vector noise, and then let's create a math mix here. And we can multiply the noise by the age, and then we can add the noise to the positions. And let's abs time dot seconds time 0.1 this, and let's see what this looks like. Oh, result scope is positions, sorry. So in the map make sure that the result scope is positions. And this way we have these traily little floaters, but as you can see, the one under the legs is also doing that, which isn't ideal. So we can delete those line strips too. So let's use our weight attribute, which we're getting from this field over here. And let's just delete any lines that are less than a certain in the weight attribute there. Yeah, and one thing good to just keep in mind that trail is just one of those things that can really crash your project if you're not careful with like how many points you're feeding into the trail, because it creates like a lot of copies of previous positions and needs to store those in real time. So it can be a little bit scary to work with sometimes. Let's turn this into a parallel noise. And yeah, there we have it. And of course you can sort of turn this field into something else, like a sphere or something. But this can be a starting point maybe to start playing with pops. So yeah, let's just check that the OBS actually recorded this one, and it did. And let's just fix this up a little bit. Let's create a floor. So we create a grid, let's rotate it 90 degrees, let's make it like size 5 by 5 by 5, and slap that into a geometry. Let's make that a... Ooh, that's why the lighting looks so bad. Let's make that a lines like this, and let's use a line material, and let's make it width near is 0 and width far can be 0, 3. Let's remove that. There's some ugly aliasing going on, we can live with it. Let's change this to 1280 by 1920, and let's move in a little bit. Let's create another PBR here, and let's maybe if we sort of turn the base color just up, which is totally physically accurate, just so they stand out a little bit more. Let's create a grab the depth buffer here, and let's just create the little 16-bit float R. We range from camera space to 3, 0.5 maybe. No, let's set that to 2, and let's set that to like 1 maybe. It's pretty narrow depth of field. Let's use a Luma blur and blur it out to like 32 based on the depth, and then we can go in a touch And let's do that with an LFO instead of just for clarity. And grab that to there. Let's turn the frequency down a touch. Yeah, and now we have a statue with little lines. And obviously this one would probably also look good with a line material here. 0, 2, 3. Ooh. Line width attribute. Right, we can use that. So we can actually take the and the trail here. We have our trail length. So let's create a little line width here. So let's create a math mix. And let's into uniform we call trail length, and we can grab this one and set that to here, and then we can say that we divide the age by the trail length to get the normalized age value. And then let's see if that's just, wait. Oh, and then it should be A minus B, so 1 minus age is the inverse or inverted age, and that can be our line width. Right, and now they sort of taper out a little bit too. So that's neat. Can set them up to be with near, maybe something like quite big, also at far away. Yeah, so we can use the attributes here. And turn our viewers off. Yeah, there we have our crazy little visual for today. Nice. And yeah, use an HDRI for your environment lights, and if we turn the environment light down, yeah, you can automate this guy so that actually can add even more noise to our lines to create even more chaos. Yeah, thank you. Support Patreon and so on and so forth. Bye.